This is AQA GCSE trilogy chemistry paper. It's the foundation paper from 2018. This is question 5. And there's an opportunity for you to pause and try the question before we review. So here is 5.1, 5.2, 5.3, 5.4, and finally 5.5. So this is an 8-mark question in total. So let's go back and do the review. 5. The question is about electrolysis. A student investigates the mass of copper produced during electrolysis of copper chloride solution. What gas is produced at the positive electrode? So in this particular case, we're looking at what ions would be attracted to the positive electrode. We know they will be negative. We know that chloride ions are negative. So chloride ions will go to the positive electrode and they will form chlorine. Copper is produced at the negative electrode. Copper ions are reduced to copper. What does that tell you about the reactivity of copper? Now, this is really, really important. It tells us that copper is less reactive than hydrogen. It's one of the reasons that hydrogen is in the reactivity series when you look at that or when you learn it. Anything that's higher than hydrogen in the reactivity series, instead of the metal being produced at the cathode, hydrogen gases. And you'll be familiar with that from your work on the electrolysis of brine, sodium chloride solution. Moving on to 5.3, we've got lots of data in this table. Determine the mean mass of copper produced after 3 minutes. So I'm going to look at the mean, and I've got 0.6, 1.2, 2.4, 3.06. If I look generally, I've gone from 0.6 to 1.2 up by 0.6 in 1 minute. From 1.2 to 2.4, I've gone up by twice 0.6 in 2 minutes. So it makes sense that it would be the third minute here. It would go 0.6, 1.2, 1.8, 2.4. There is a slight anomaly with 5 that, it doesn't impact on the result. And you would have been okay if you'd gone slightly away from 1.8 on either side. 5.4, calculate the mass of X produced in experiment 2 after 5 minutes. So what we have here is experiment 1 and experiment 3 data, and we have a mean. But we have X. So instead of working out the mean, which is a common question, we're saying 3.02 plus X plus 3.01 divided by 3 is equal to 3.06. Let's multiply both sides by 3. So I've got 9.18 is 3.02 plus X plus 3.01. And actually, if I then rearrange it to make X the subject, 9.18, take away the 3.02 and the 3.01, it gives me a mass of 3.15 milligrams. And on to 5.5, the copper chloride solution used in the investigation contained 300 grams per decimeter cubed of solid copper chloride dissolved in 1 decimeter cubed of water. The student used 50 centimeter cubed of copper chloride solution in each experiment. So we didn't use a decimeter cubed, we used 50 centimeter cubed, 1/20th of that. So volume of CuCl2 is 50 centimeter cubed, which is 0.05 decimeters cubed. We had 300 grams in 1 decimeter cubed, so my mass in 50 centimeter cubed will be 300 multiplied by the 0.05, giving me a mass of 15 grams. And just to show that again, 0.05 is 1/20th of 1, 15 is 1/20th of 300. And that takes us to the end of that question.